we need to look at Lami's theorem. We saw the triangle forces for three forces that can be drawn in form of a triangle. There is a certain other generalization we can make from three forces in equilibrium particularly. We are saying that suppose the forces P, Q, and R acting at a point are in equilibrium. If these forces are in equilibrium, you can say they are three forces. It means that they can be made into a triangle of forces. They can be made into a triangle of forces like so. Let me draw it here in a sketch before I can shift to that point. You have a force P acting upwards, and you have another force at the end of P. You have another force, this force acting like that is force R, and then you have at the end of R you have that force. Let me try to do some bit of extrapolations. And actually, yeah, have that. This one is P, then this one is R, and you have the force Q. You can look at the way the angles, the inclination of the forces. I'm extrapolating this side so that Q is moving in that direction, and the angle between P and Q can be got from here. Remember, the force P, the angle between P is there, and the angle between P and R, extrapolate that and assume as if P is going up there. The angle between P and R is beta, that is beta. Then extrapolate this so that this is the angle between R and Q, which is alpha. And by looking at those angles, you realize that this angle is 180 minus beta. This angle is 180 minus alpha. And this angle is 180 minus gamma. That is precisely what we have in this diagram here. You extrapolate. I remember I told you that the force, the angle between two forces can be got when the forces are both of them outwards. So this force out from point B, it is out from here. This one out, then this one should also be extrapolated so that they are almost, or so that all of them are moving outwards. So it should be that direction. And so that's the angle B, beta, the angle alpha, the angle gamma. And now when you use the sine rule, this is 180 minus beta, 180 minus alpha, this angle, and this other angle here is 180 minus gamma. And so if you have to use the sine rule, by the sine rule, we have that this is the force Q. I can start with the P. P divided by the sine of 180 minus alpha is equal to Q divided by the sine. This is the force Q divided by the sine of the angle opposite. 180 minus beta. It should be equal to R divided by the sine of the angle which is opposite R, is that 180 minus gamma. That is what we get from the sine rule. And now the sine of 180 minus alpha is the same as the sine of alpha. Sine of 180 minus theta is the same as the sine of theta. These two things are the same. So this one can be, it means that we can write these things as P over sine alpha equal to Q over sine beta is equal to R over sine of 180 minus gamma, which is sine of gamma. This one here can be known as Lami's theorem. It is being derived from the sine rule for three forces acting at a point which are in equilibrium. That is what we have there. And the implication is that, remember, it is saying that P divided by sine of alpha is equal to Q over sine of beta equal to R over sine of gamma. So just have this one, then the angle opposite. So you have R angle there, P sine of this angle, Q over sine of that angle. That is Lami's theorem. And this example can try to illustrate something. We look at, we can use Lami's theorem. But when you are to use Lami's theorem, you must have, for the three angles, have this, have that, and that. Now when we look at this diagram, this angle is 180 minus 45, which is 135. When we look at this angle here, this angle is 180 minus 150, which is equal to 30 degrees. And if we are to use Lami's theorem, we shall take care of that angle, and that angle is an angle of 75. So by writing this, we have that we shall say that P over sine of 75, which is this angle, is equal to Q over sine of 135 is equal to 8 over sine of 150, which is that one there. And from there, we can equate these two and find the value of Q, because here it means that Q, I'm writing from there downwards here, I have that Q is equal to 8 times sine of 135 degrees divided by sine of 150 degrees. And if you work out there, you are going to get a value of Q, which is equal to, the value of Q you are going to get will be 11.3 degrees. Then you also equate, if these two are equal, if all the three are equal, then these two are equal, and even these two are equal. So we have, the other thing is that P divided by sine of 75 degrees is equal to 8 over sine of 150 degrees. And that one is supposed to imply that P is equal to 8 times sine of 75 degrees divided by sine of 150 degrees, implying that P, if you work out from your calculator, is 15.5 newtons. That is, this one is not degrees, man. This one is, it is newtons, because it is a force. There you are. That is the first example. We have this example also. They are saying that one end of an inextensible string is fixed to a vertical pole, and the other end carries a particle of weight 8 newtons. The particle is held in equilibrium with the string at an angle of 30 degrees with the pole by means of a force acting at right angles to the string. Find the value of the force and the tension in the string. We can try to imagine this, what is happening. You have a string fixed. Maybe you have a string and you are holding it by a force F perpendicular to the string. There is a force of 8 newtons and you have a vertical pole. That is basically what we have. Let me try to draw this diagram properly for you so that you can see it. That one happens to be the analysis of what these words are telling us. Angle 30, they said it is held in equilibrium with the string at an angle of 30 with the pole. So the pole, assuming this is our pole, this is the fixed point. You have fixed it there at 30, and you are holding it from here. The force is applied is there. They say the force is at 90 degrees to the string. So we are having that. And now there will be a tension in the string because it is holding this weight down here. So there will be some tension set up in the string. So to use Lami's theorem, we are going to need this angle and that angle there. But this first angle, first of all, this angle is 30 degrees. Why? Because this angle being 30, if I extrapolate that and this right angle is there, this angle is 60 degrees. And 60 there, then 90, this should be 30 because the angle in the straight line gives us 180. This one being 30 and this one 90, we know we are going to use this angle as 120. Then you also need to use this angle as 150. So Lami's theorem, F is opposite a force of 150. T is opposite, F is opposite an angle of 150 and T is opposite an angle of 90 plus 30, which is 120. So if I'm to use Lami's theorem to work out this, I now have that F divided by sine of 150 degrees is equal to T divided by that one is 120 degrees. It is equal to 8 divided by sine of 90 degrees, because the 8 here, the 8 newton here, the angle opposite is 90 degrees. So we shall have that you work out n of the two, equate this and that, and you have that T is equal to 8 times sine of 120 degrees divided by sine of 90, which is of course equal to 1, and that will get us a T which is equal to 60.93 newtons. Then you also equate, since the three are equal, this F is also equal to is equal to that expression. So we have that F divided by sine of 150 degrees is also equal to 8 over sine of 90, which is equal to just 8. And so we have that F is equal to 8 times sine of 150 degrees, getting us F as 4 newtons, because the sine of 150 is the same as the sine of 30, which is 0.5 times 8, that one is 4. That one is the answer. That's the solution to that expression. Your concern is this diagram is not given to you in an exam, so you are supposed to understand this question and draw a picture and imagine it and draw this diagram here. What happens when you have a force and you have a force at the right angle to the string, and then a weight of 8 newtons is acting downwards? You see, I was supposed to do that and get that solution. Now, as for this example, they have drawn for us a diagram, but they are saying that the diagram shows a right inextensible string. I didn't talk about this term in the first example. It was there. If they talk of the word inextensible, it means that the length of the string involved is not going to change just by applying the force. It means that that string is not elastic, it is inelastic. That even when the forces are being applied there, the length remains unaltered. So we have a light inextensible string with one end fixed at A and a mass of 5 kilograms suspended at the other end. We are there. The mass is held in equilibrium at an angle theta to the downward vertical by a horizontal force P. The force P is there. Find theta by trigonometry and then use Lami's theorem to find the magnitude of the force P. And attention, we have been very particular here to tell you that use trigonometry to get this and use Lami's theorem. But the question examiners want to say they don't give you the method to use. They just want you to find the value of theta and then the value of P and T without having to tell you that you are supposed to use either Lami's theorem or what. We shall do what they told us to do. They told us to use trigonometry. So by trigonometry, we can get, they said use trigonometry. Actually, angle theta is, I didn't indicate it in my file. You are going to indicate it yourself. We have theta. We can use the fact that this side is opposite, this is adjacent. So we can say that tangent of theta is opposite, which is 30, divided by adjacent, which is 40, 3 over 4, and we have that theta is the arc tan of, you are there, that one is 36.9 degrees. That's the value of theta. Now after getting theta, we also need to get this angle. Remember, if you have to use Lami's theorem, you can call that angle alpha. Alpha is equal to 90 minus 36.9, which is equal to 53.1 degrees, I think. And when you have that as 53.1, then the angle we are going to use here, opposite to angle P, the one we are going to use is this one. That angle is 90. We have 90 plus 53.1, which is equal to 143.1 degrees. While for this other side here, the one we are going to use for as the angle which is opposite to the 5 Newton force, we are going to use this angle. We are going to use this. Oh man, not that penny. We are going to use that angle, and that angle is 180 minus alpha. And if you work out, that angle is 126.9 degrees. So if we are to apply Lami's theorem now, Lami's theorem is, remember, we can have it from something like that. You have the force. This is Lami's theorem. Angle opposite, alpha, beta, gamma. You have Q over sine alpha. You have this is P. Oh, okay, let it be R. You have R over sine beta. You have P over sine gamma. One of these should be gamma, so this one is the gamma. That is what we do. So we are going to say that by Lami's theorem, you are supposed to write there, like you are supposed to write that expression when in an exam. By Lami's theorem, 5G This one is not 5 grams, it is 5 times gravitational acceleration, because a particle of weight, a particle of mass, 5 kilograms, will have a weight of 5g, where g is not gram, but it is the gravitational acceleration, which is 9.1, 9.8. We normally use 9.8 in mathematics, but in physics we use, I think, 9.81, because in physics accuracy is more important than brevity, because in mathematics we want something which is somehow breve. So we have that 5g divided by sine of that angle, which is 126.9 degrees, is equal to p divided by the angle opposite that in the Lami theorem thing, 140. This one is sine of 143.1 degrees. It is equal to t divided by the sine. Actually, it is opposite an angle of 90. Opposite an angle of 90 degrees, so we can have just that. Then we can equate any two of them, equate these two and get the value of p. So p itself is equal to 5g times the sine of 143.1 degrees divided by sine of 126.9 degrees, and the value of p you are going to get from your calculator will be 36.80 newtons. If you equate this one and that, equate those two, you have that 5g divided by sine of 126.9 degrees is equal to t, such that t is equal to this one. If you work out, remember g is equal to 9.8. That's the value you are going to put wherever you see that g. And if you substitute there, where you put g where it is supposed to be, you are going to get that t is equal to 61.3 newtons. Those are the values you get. Use trigonometry to get theta. Use Lami theorem to get the value of p, the value of t. And you see, when you use Lami theorem, the force, the angle opposite this whole chunk of the angle, the force down, sine of that angle, the force up there, sine of this angle opposite. It is like that. This one is saying that a particle of weight 49 is suspended by means of two inextensible strings. This one should be strings of length 21 centimeters and 72 centimeters, fixed in the same horizontal line, 75 centimeters apart. Find the tension in the strings. This diagram is not part of the solution, it's not part of the question, it is a solution. So the question ends here, and you are supposed to come up with this diagram. The horizontal line onto which they are fixing the strings is the line AB. So both of them are fixed on the same horizontal line. One is fixed at A, one is fixed at B, and AB is 75 centimeters. 75 centimeters. They told us that the strings are inextensible, and by having one who has 72 centimeters and having another has 21 centimeters, of course they can't be along the line AB, because 72 plus 21, it is longer than the 75. because this one will get us 93, and 93 is far longer than the 75. So the diagram should be in that form. It should be hanging. They should be hanging like the way you have them there. And now we can apply Pythagoras theorem on the sides of the triangle, and we have that actually not Pythagoras theorem here. This one should be, because we don't know which angle is this. There is no right angle here, but let us try to use the cosine rule. The fact is that when I get 75 squared, I should get 72 squared plus 21 squared minus 2 times 72 times 21 times cosine of the angle which is opposite 75. That one is theta. I'm using that to get the value of theta. These angles alpha and beta were not known, they are not given, but after setting up this line here, I have that this angle is alternating with that, so it is also beta. This angle is alpha, just like that, alternating angles. This one is something I've just drawn there to ensure that I have this t inclined to a certain known angle. But for this particular one, for this one, we have that cosine of theta is equal to 72 squared plus 21 squared minus 75 squared divided by 2 times 72 times 21. When you work out this, you are going to get a 0, and you shall see that theta is the cos inverse of 0, which is equal to 90 degrees. So 90 is the angle between the between the tension is involved. They are at right angles to one another. So we need to get they talked about we are going to make one assumption, assuming equilibrium. We are going to use Lami theorem. So we shall need to get this angle. We are going to get this angle so that we can use Lami theorem. And also we are going to need this angle also. Those two angles are going to be needed. The latter one is 90 plus beta, while this other one is 90 plus alpha. So it seems that we need to get the alpha and the beta are angles which are really needed here. We need to get the value of alpha and the value of the angle beta. We are going to use the sine rule. We can use the sine rule in a triangle. Even after establishing the fact that this one is right angled, still we can use the sine rule, or we can just say use this trigonometry, but I'm going to maintain the sine rule. So we have but that by the sine rule we have sine theta divided by 75. That is the sine of this angle divided by the side which is opposite to that. Then it is equal to sine beta divided by the side which is 72, also equal to sine alpha divided by 21. If I equate those two, I have that sine of 90 degrees over 75 is equal to sine beta over 72, such that beta is equal to sine inverse of 72 sine 90. Remember, sine 90 is the same as 1, so this is over 75. The value of beta you're going to get there is is 74 degrees. Then when we have that, equating this, also when you equate this one and that one, equate those two, sine theta over 75 is also equal to sine alpha. So I have that sine alpha is equal to 21 times sine of 90 divided by 75, and alpha is equal to 16 degrees. Now we have got those two angles, we have got alpha and beta. We can now get the angles we are going to apply in Lami's theorem. Now by Lami's theorem, by applying Lami's theorem, we are going to have that 49 divided by sine of 90. Actually, the angle there is theta. It should be equal to T1 divided by T1 is opposite this angle here, this one. So we are going to have T1 divided by that angle, which is 90 plus beta. That is what we have. So it is T1 over sine of 90 plus beta. It is also equal to T2 over sine of 90 plus alpha. That is the angle we have there. And now theta, remember theta is 90, so we have that that T1 divided by cosine of beta. That is from trigonometry. The sine of 90 plus beta is the same as the cosine of beta, is equal to 49. So we have that T1 is equal to 49 times the cosine of beta, which we got as 74 degrees. And so T1 is equal to, the value of T1 we are going to get there is, if you work out that, we are going to get 13.5 newtons. And then here we also have that T2 over cos of alpha is still equal to 49, equating this one and this one here. So we have that T2 is equal to 49 times it is 49 times the cosine of alpha. We got alpha as 16 degrees, so we have that T2 is going to get us 47.1 newtons. That's what we have there. If you have any queries, you can always send me a message on the Telegram group. The channel, you can watch the videos, but you can respond through the group. The link is there. You can always contact me. This is another example, guys. The diagram shows a board of mass 5 kilograms supported by 2 light inextensible strings, the other ends of which are attached to 2 points A and B on the same level as each other and 7 centimeters apart. That means that AB is 7 centimeters. So you have fixed the strings at A and B, and they are hanging in equilibrium. They are saying the body rests in equilibrium at C, 3 centimeters vertically, 3 meters vertically. So it means that this height here, this height, this one is 3 meters. 3 meters vertically above it is here below AB. That is what we have. That's not angle CBA. If angle CBA, this is the angle they are talking about. If angle CBA is 45 degrees, find T1 and T2. T1 and T2. The tension is in the string. We can try to summarize this thing. 7 centimeters apart, AB 7, 3 meters, 45. We can solve this. I have tried to put some things that can help us to solve the problem. Particularly, I put the angle theta. We can find it. So look at triangle OBC. If I look at tangent of 45 degrees is equal to tan of 45 is opposite 3 meters divided by adjacent, which is OB. And that means that if I want to get OB, I get 3 divided by tangent of 45 degrees. That is 3 over 1. So OB is equal to 3 meters. And if OB is 3 meters, it implies that OA is equal to 4 meters, because remember AB is 7. So if this one is 3, this one is 7 minus 3, which is 4 meters. And if that is 4 meters, I can again say that tangent of theta is opposite, which is 3, divided by adjacent, which is 4. And theta is equal to tan inverse of 3 over 4. Theta is equal to 36.9 degrees. That is the value of theta. And now we can make use of Lami's theorem. According to Lami, we are supposed to have that T1 divided by sine of 135 degrees. 135 is T1, the angle opposite to the force T1 is, we are talking about this angle here, this one here, that angle. So you have T1 over sine of that angle. It is 90 plus 40 plus 45. Then we have, we also have that that one is equal to T2 divided by sine of 90 plus theta. And for that one, we are saying that T2 divided by the sine of this angle. Sine of that angle. We have the 90 and then the theta. It should be equal to, it is further equal to, it is equal to 5g divided by the sine of now that angle. We can get it. It is 180. That angle is 180 minus 45 plus theta, which is 36.9, and that angle is basically 98.1 degrees. The angle I'm talking about is this angle here, that angle. So we have 5g divided by sine of that angle. So we have, it is now sine of 98.1 degrees. And you remember what we talked about, sine of 90 plus theta, the same as the sine of theta. So we can say that we get T1 by equating T1 and the last expression. T1 over sine of 135 degrees is equal to 5 times 9.8 divided by sine of 98.1 degrees. Find that T1 is equal to 5 times 9.8 divided by sine of 98.1 degrees. And the value of T1 you are going to get there is 35 newtons. That is if you write it to the nearest whole number. Then T2 divided by cosine of theta is equal to 5g, which is 5 times 9.8 over sine of 98.1 degrees. And so we have, we shall have that T2 is equal to 5 times 9.8, and we shall divide by, that is divided by, oh, there is, yeah, we multiply cos theta times cosine of 36.9, and we divide by sine of 98.1 degrees. And when you work out that, you are going to get a value of theta, which is 39.6 newtons. So T1 is, if I write this one to the nearest number, it is 40 newtons. But you know what you are going to get from your calculator when you press. So that is what you do. You work it out like that. Let's look at this example. The figure is given here, and they are talking about it as the figure above represents the weight W, this weight here, attached to two strings which pass over two smooth pegs A and B at the same horizontal level, and support weights P and Q at their free ends. Prove that in the position of equilibrium, this one is true. Sine theta equal to that. They are talking about equilibrium, and there are forces which are not shown here. By this thing being like this, there are some forces which they have not indicated. For instance, this angle is beta because it is alternating with this beta here. Is theta because it is alternating with that theta. There is a tension acting on this weight. There is a tension. I prefer to call that T2 because I want to have T1 on this side. And they said that the pegs are smooth. If I have a smooth peg, the tension is on two sides of a smooth peg should be the same. So that means that this side also the tension is T2, and even this side the tension is T1. That is what we have. Why are we doing that? Why can we say that the tension is, this one is T2 just like the way it is this side? Because the tension here along this string, through this string, the tension exactly there is T2. Then because this one is smooth, as I told you, they said the pegs are smooth, the tension is on the two sides of the peg should be the same. So the tension in this side is equivalent to the tension in that side. The same applies to this. The tension in this side should be the same as the tension in that side, reason being the pegs are smooth. And then the another thing which they told us is that is this equilibrium. If this system is in equilibrium, it means that there is no tendency of anything to be moving around. So there is no resultant force at any point. That one is supposed to mean that T1 is equal to P. It also means that T2 is equal to Q. Because if those two are not the same, if T1 is not the same as P, if T2, for example, T1 is greater than P, this thing will be moving upwards. And if P is greater than T1, it would be moving downwards. And that is not equilibrium. So equilibrium, since this is a static equilibrium, there is no motion taking place. So the two must counterbalance. And even when they are even if there is motion in a constant motion, because it is dynamic equilibrium, we should still have that the forces which are that T1 still will be equal to P, because for that body to move with a constant speed, the forces acting on the system, the acting forces, there must be counterbalancing. So either way, whether dynamic or static, should have that those two forces are the same. Now we can look at the forces which are exerted on the weight. Horizontally, you are supposed to write that resolving horizontally before you write this statement. So resolving horizontally, we have T1 times the cosine of theta is equal to T2 times the cosine of beta. The horizontal component of T1 is towards the left. It should counterbalance the horizontal component which is acting towards the right. That is for state of equilibrium. You can see that the T1, its horizontal component is towards the left. So the forces towards the left should be equivalent to the forces acting towards the right. And that is what is happening horizontally. But remember T1 is P. So we have P cosine of theta and T2 is Q. So this one is Q cosine of beta. I can call this one equation number 1. Then you can write and say that resolving vertically shall look at the vertical resolution. The vertical component of T2 plus the vertical component of T1, both of those forces are acting upwards. So the sum of the upward forces, which are the vertical components of those two tension forces, they should counterbalance the weight. They should counterbalance this weight acting downwards. The weight is supposed to act downwards. So we are supposed to have that T1 times the sine of theta plus T2 sine of beta. They should give us W. But remember what is T1? And T2 that is equal to W. And now we can call this one equation number 2. From this equation number 2, when we look at our proof, when we look at what we are turning to, we are having sine theta and there is nothing else here. We have the W is the forces only. So it means that here our task is to eliminate beta. Eliminate beta from the equation is. So what we are going to do, we are going to say that from equation 2, Q sine beta is equal to W minus P sine theta. And what we are going to do, we are going to get equation 1. Actually, let this one be the one I call equation 2. The one which I've got Q sine beta being equal to this one minus that. So we are going to get equation 1 squared plus equation 2 squared. When I square that, I'm eliminating, so I shall have this one Q squared, that is Q squared cos squared beta plus this one Q squared sine squared beta. What I get is, for the first one I get P squared cos squared theta plus this one is W minus P sine theta squared. That's what we call squaring the two equations and adding them. I have the left hand side. Actually this one, for this one I use the right hand side, and then here I'm looking at this and this. I can write the first one can be written as, I can write the first one as Q cos beta equal to P cos theta. So left hand side of equation 1 squared plus left hand side of equation 2 squared. Then the right hand side follows suit also. Square it and you are there. So when we look at this one is Q squared into cos squared beta plus sine squared beta equaling to this one is P squared cos squared theta plus this one will get us W squared minus 2 WP sine theta plus P squared sine squared theta. And we have Q squared into, that one is 1. This sort of thing will give us one from Pythagoras. It is Pythagoras theorem. when we're looking at trigonometry. So this one is again p squared into cos squared theta plus sine squared theta. That's another one. This one is taking care of this and that. Then plus w squared minus 2wp sine of theta. This is another one again. So you have that q squared is equal to p squared plus w squared minus 2wp sine of theta. Take this one to the left. You will have 2wp sine theta equal to p squared plus w squared minus q squared, such that sine theta, I can just write the proof. It is w squared plus p squared minus q squared divided by 2wp, and that is as required. That is what you are supposed to do. Result of forces acting on the weight. Then at this point the pegs are smooth. Tension in here is the same as tension there. Tension here is the same as tension there. That is what we have there. There is this number also. They are saying the given forces act on a particle O which is in equilibrium. By resolving in two directions, find P and S. So we have these are the number of forces. They are saying that they are in equilibrium. There are many ways we can use to solve them. We could use Lami theorem. We can use triangle forces. We can use, but we cannot use triangle forces actually, because there are not three forces here. We can't use it. Even Lami theorem cannot be applied, because it is also derived from a triangle forces. So we have only one option of we need to resolve them in two directions. So what we are going to do, we shall resolve parallel, resolve horizontally. When you resolve horizontally, you realize that P does not bear a horizontal component because it is purely vertical. It is perpendicular to the horizontal, so it has no horizontal component. And now the forces which are horizontal, which bear a horizontal component, force S has a horizontal component directed towards the left. It is negative. Then this one has a component towards the right. It is positive. This one is also positive. So when I resolve horizontally, I have the 7 horizontal component of this force. It is 7 times cosine of 60 degrees. I add on the horizontal component of that, which is 10. Then I subtract. It should be counterbalanced with S times cosine of 30 degrees, implying that S is equal to 7 cosine of 60 degrees plus 10, and I'm going to divide this by cosine of 30 degrees. And when I work out this S is equal to, first of all, cosine of 60 is a half, so this one is 3.5 plus 10 divided by cosine of 30 is root 3 over 2. So this one is going to get us a value of S, which is equal to, it is getting us 9. Actually this one is, let me put this one is 13.5 times 2 divided by root 3, and this one will get us 27 over root 3. Another person, you could write this one as 9 root 3 Newton is, because by root 3, if you try to rationalize the denominator, we're going to get a 3 down there and a root 3 up, then 27 over 3, that one is 9. So that is 9 root 3. You can work it out with from the calculator, work it out and get the actual value in terms of decimal places. We can also try to resolve vertically. We have these two forces P and 7, they have vertical components. This 10 is purely horizontal, so it bears no horizontal component. But this 7 and this P, they have a vertical component. Even this one has a vertical component. So we get the components that are acting vertically upwards. We counterbalance them against those which are acting vertically downwards. So we are going to have, this one is P, that one is just P, because for it is acting vertically upwards, there is nothing there. But the vertical component of 7 is 7 sine of 60 degrees. I could write this one as 7 cosine of 30 degrees, because from the definition of a component, so the component of the 7 Newton force along the vertical is given by the product of the force itself times the cosine of the angle between the force and the direction in consideration, in which case this time it is the vertical. So you can have this or have this. This one is good from using the fact that I'm looking for the vertical, so the component can act along this side which is opposite to this one. So we have P 7 times sine of 60 degrees. That one should counterbalance against this S, because S for it is acting, the vertical component of S is acting downwards. So we have S times sine of 30 degrees. We have already got S. P is equal to, we are taking this on that side. So we have S sine of 30 is 1 over 2 to 3 over 2. And remember, we already have S as 9 root 3, then a half, then minus 7 root 3 over 2. So this one will get us a value of P, which is equal to, there is a root 2, there is a 9, actually this one is 9 minus 7 into root 3 over 2, which will get us 2 root 3 over 2, which is equal to root 3. So the value of P is square root of 3 newtons.